So, good morning. We are starting with programming practices and techniques, and we have from session 1 to session 11. And the name of the course is programming practices and techniques. So, let's get started. Perfectly open it. No, so, there it is. It's a bit slow. It's a bit slow. Anyway, try again. Click open with Chrome. So, session one, introduction to computers. I think like I'll just go through it. Like I'll just brush it. It's not a big deal. Introduction to computers. We all know that, right? Right from our daycare schools and the rest. So, objectives of this session is we have define a computer system, describe part of computer, explain the computer system startup process, list new technologies in computer. So, introduction. Here, they said a computer can be defined as a system that responds to a set of instructions in a well-defined manner. A computer can be defined as a system that responds to a set of instructions in a well-defined manner. The computer system consists of different parts, namely central processing unit, CPU, that central processing unit, motherboard, random access memory, hard disk, main cabinet with all the peripheral devices connected to the motherboard, and then the operating system. So all these are what different parts of a computer system: CPU, motherboard, random access memory, hard disk, main cabinet with all the peripheral devices connected to the motherboard. These peripheral devices are just like mouse, speakers, joysticks, and the rest. So, all of them are connected to the motherboard, right? Like you have to plug in something in it. Sorry, what's this? So, then the operating system itself, it's the the operating system is like what operating system is right like the Windows, Android, Mac, iOS, blah blah blah. So that's it. I think this place, since it is introduction, just it's self-explanatory. CPU, central processing unit, motherboard, the engine gongo, then random access memory, the RAM, hard disk, where the memory is, and then like where the secondary storage is. Like when you save your files or anything, it's saved inside the it is saved inside the what's it called hard disk. Then RAM is the where random access memory is like when you are working, that's where your work is before when you save it, it will go to hard disk. And then without RAM, your display screen will not show, like this place will be black. You get, if without RAM in your system, it won't work. So your screen won't display. So we have types of computers. Computers can be classified based on their size and processing power. Different types of computer as follows. We have personal computers. We have workstation, mini computer, and then supercomputer. I believe they've explained each and every listed stuff there. So personal computers or microcomputers, they are relatively small as compared to supercomputers and mainframe computers. So they are inexpensive and designed for individual users. They are used in business, homes, and schools for surfing internet, playing games, listening to music, and then so on. So personal computer here is just like me, your laptop, my laptop. You get just laptop. That's personal computer. Then they come in different forms such as desktop computers, laptop computers, tablets, PCs, personal digital assistant (PDAs), and then and so on. So, personal computer, the computer you use for your day-to-day work and then anything, everything. That's like your laptop, your iPad, your PDA, personal digital assistant. Do you know PDA? Just like there's one. It's a small device like that. They use it for, let's say, maybe when they are doing registration, maybe all this kind of they use it to like collect data from people. Like maybe it's very small. It's very small. They use it for collection of data and just so on. So personal computer. Okay, here we have a problem here. So we have a problem here. The write up it's mixed up. I believe yours too it's like that. So what we will do is that I'll copy it and then I'll take it to Notepad and arrange it. So what I'll do is I'll click on Windows R, type Notepad on my Notepad. So what I'll do is that I'll copy it. Um, so alright, so copy it. Oh, why it's copying challenge? Control C, and then I'll paste it here. So this is it. This stuff here. Desktop computers. I said these computers are not portable and are designed to fit on desk. Like it's self-explanatory. They are much smaller in size, like desktop computers. You know what desktop computer is, right? They are smaller in size, easy to use, and cheap as compared to other types of PC. They are mostly commonly used in office, homes, cyber cafe, and then so on. Then laptop computers are lightweight and portable. Physical size of a laptop is a primary factor that determines the cost of a laptop. And laptops that are smaller in size are known as notebooks. So that's it. You can likewise do the same. So then uh, then PDA. I don't know. Control C. Open my notepad. Once we're done with this one, remove it. I'll paste it. So a PDA, also known as a palm-top computer or a pocket PC, is a handheld miniature computer. Palm top. They are smaller and lighter in weight and can be carried in a pocket. These devices hold data such as schedules, notes, appointments, address book, and many more. Mobile phones that are integrated with PDA functionality are called smartphones. So most of our smartphones they are integrated with what? With the personal digital assistant. That's PDA. So that's it. That's it. So then workstation. Workstation can be defined as a type of computer that is mainly used for technical and then scientific applications, desktop publishing, and so on. Like the computers they use in get radio, get TV, in like places they do huge of works. So they are used by a single person and are connected to a local area network. Suppose they are connected to a local area network as LAN. Sometimes it mustn't necessarily be internet, just in a local area network. Then it has a moderate computing power and a high quality graphic capability. Then workstations have built-in network support, mass storage device, graphical user interface, and so on. So the computers they use in work, like maybe two, three, four, five, six computers grouped together for work. It's called a workstation. So mini computer is a multi-user computer and supports hundreds of users concurrently. Mini computer, we all know what mini computer is. What mini computer is. They are smaller to mainframe computers as far as speed, performance, and storage capacity. When compared with mainframes, they are less expensive than supercomputer. Supercomputers are fast computers that can execute trillions of instructions per second. Just imagine it can execute trillions of instructions per second. Trillions of instructions. Just imagine how mighty this computer is. They are used by applications that require intensive numerical computation, such as weather forecasting, nuclear energy research, oil and gas exploration. If you know about all these nuclear weapons, all these weather forecast, oil and gas exploration. Of course, it's a big something, so definitely they have to use mighty computers like all these sophisticated systems, all these sophisticated computers. Hmm. So these sophisticated computers are called supercomputers or mainframe computers. You get. So mostly they use them in weather forecasting, nuclear energy research, all these nuclear weapons, and then blah blah blah, oil and gas exploration, and so on. Then mainframe is a large computer that can support hundreds of thousands of users simultaneously. Mm. Like, for example, Google server, they also have a system there. They use supercomputers to get millions of people, give them data and the rest. So mainframe computer is incredibly huge and then big and fast and anything you can think of. So various components of computer system. We have keyboard, hard disk, mouse, joysticks, and then these are the pictures. You're familiar with them, so it's not a big deal. Oh. So computer software and types. We have software is a generic for organized collection of computer data and instructions. A sequence of instructions is specified to a computer to solve a problem. This sequence of instructions are written in a language which can be comprehended by a computer and they form a computer program. And the program controls the processing of the computer, which performs specifically as the program instructs. So here, computer software. Software is just like collections of data, right, and instructions. Collection of data and instructions. Then, when it's collected together, it performs its own operation and it produces functionalities. That's what software is. Software, you have different kind of softwares. Um, this browser that we open this what's it called this light. It's also called a software. Like all these things you see on the desktop. These NetBeans, video converter, blah blah blah. All those ones they are called what software. So they are collections of computer data and instructions. They are instructions. You have to instruct it. You have to collect data and instruct whatever you're instructing to produce the software. That's it. This sequence of instructions are written in a language. Definitely, they're written in a language, not my language, not your language, not Hausa, not English, but it has its own specific language to produce to develop a software. And those languages are we have Java, C Sharp, JavaScript, and then etc. Then the program controls the processing of the computer which performs specifically as the program instructs. So there are two types of software. Namely, we have system software and then we have application software. like system software and then application software. So let's see what system software is. Here, there's a system software device. We have device drivers, operating system, servers, and then utilities. While application software, we have software, business software, computer games, media software, military software, and blah 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 blah. Spreadsheets, word processors, decision making software. So here, system software, it's that software that comes with the computer. Like it's system software. It maintains um, the well-being of the computer, if I can put it that way. System software, it maintains the well-being of the computer. Like the computer has to work perfectly. And then this system software is here. They said we have device drivers. I don't know if you know about drivers. Sometimes your system might malfunction. Maybe sometimes you might have a problem with your system. Maybe the what's it called? The speaker is not working. Like it's not voicing out anything. And then maybe they've checked the hardware and they see everything. It's normal. Babu anywhere and they think like um no any problem from the hardware. Then what you need to do is you have to install a driver. Get it will drive the system. Then if you drive it, everything will work perfect. Your speaker will come back to normal. Everything will work perfectly. So here, system software drivers are system softwares. Driver is what to drive your system to make sure every part of your system is working perfectly. Like the inner part of the system is working perfectly to drive the OS, the operating system. So system software, we have drivers, we have operating system. Like without operating system, there's no computer. Do you understand? Without operating system, without computer, there's no computer. So operating system is also a system software. Then servers also it maintains the functionality of the system. Server where you store your like all these websites we are browsing, we are you know doing stuff with everything there on server, your WhatsApp, your Instagram, your YouTube, your whatsoever that's online, it's definitely on a server. So a server is also a system software. Then a utility software is just like the utility antivirus. It's a type of utility software. And you see antivirus also is what is used to maintain the well-being of the system. If the system if the system is affected with virus, definitely you have to use antivirus to get rid of that virus. So also utilities are part of system software. Do you get it? While application software is our day-to-day work software. It doesn't have to do with maintaining the system, maintaining the computer. I hope you're getting it. Like business software, of course, is our own personal needs. Computer games for games, medical software, like all these um, IIS softwares for medical hospital management system (HIS). Then medical software, military software, photo editing software, especially as you can see, these application software are all those softwares that we use that helps an individual to perform his day-to-day needs on the computer. You understand what processor, decision making software. So application software are just for um, it helps an individual to perform some certain task on the system, while system software is used to maintain the well-being of the computer, to maintain the functionality of the system. While application software are those softwares we use in our day-to-day life, games, um, for photo editing software, spreadsheet, that's Excel, word processors, Microsoft Word, decision making, business software, and so on. So I hope you're getting it. So that's it. Oh, what's this? So here too there's a problem where we do it computer system boot process. We copy it, right click, Control C, then we open oh Where is it? Okay. I'll open this. I'll right click computer. I'll control B. So computer boot process system. So here they said in order to boot a computer successfully, its basic input output system. In order to boot, you know what's booting? Like when you on your computer at the process of running, like loading. That's what booting is. Hmm? It doesn't just pop up just like that. Pop. It has to load. So that loading is called computer booting process. So in order to boot a computer successfully, its basic input output system, operating system, and hardware components must work properly. Hmm? In order to boot a computer successfully, like in order to load your system successfully, its basic input output system, BIOS, basic input output system, BIOS, which is input, uh, your keyboard, output, your monitor, speaker, system, operating system itself, the Windows like Windows 7, Windows 8, Windows 10, and the hardware components like the monitor and the rest have to work properly before it's successfully boot. Before it will what? Before it will successfully boot. So basic input output system BIOS, it's that's where your timing, your passwords, and your timing, that's your calendar timing, passwords, that's where they are stored. It's a chip, it's just like a device. It's more chip inside the system. Like if you see it, it's just like like a like a like a watch battery, wrist watch battery, but it's bigger, of course. So that's where your password is. Sometimes when you like, especially in desktop, in your what's it called, CPU, system unit. When you open it, when maybe you've forgotten your password, when you when you lose your system, you there's a BIOS there. When you remove the BIOS and put it back, that password is gone. You have to put another password. So that's it. So those three have to work perfectly before you have a successful booting. Like the BIOS, the OS as the Windows, and the hardware components, what's it called, the keyboard, monitor, and the rest. It has to work perfectly before you have a successful boot system. Then failure of any of these three elements will likely result in a failed boot sequence. Mhm. See, failure of any of it will likely result in a failed boot sequence. If one of it is not working properly, then it will you have a problem. Then BIOS is a microchip that stores instructions such as post in a predetermined memory address. It stores instructions just like the timing and the passwords. Then once the post determines that all components I hope you are getting it. Once the post determines that all components are functioning properly and the processor has successfully been initialized, then the BIOS look for the OS and its boot sequence in the MBR master boot record. So BIOS is a microchip that stores instructions such as post in a predetermined memory address. It stores instructions in a what? Such as post. Furnish cannot post. So once the post determines that all components are functioning properly, so here once the post check that okay, in the BIOS itself, the operating system and the hardware they are working fine, what it does is that it tells the BIOS to look for an OS. Do you get it? Once the post determines that all components are functioning properly and the processor has successfully been initialized, then here the work of post is that it will make sure that all these three elements are working perfectly. Do you get it? So after that, the BIOS look for an OS. The BIOS look for an OS and its boot sequence in MBR. So here, the work of BIOS is to go and look for an OS after post have checked that everything is working perfectly. Then the BIOS will look for an OS. And look at it like in a seconds, minutes, seconds. Cool. It happens. That's why when unloading in the again, that loading that it's when unloading in them, that's where all this stuff is happening within seconds. So the BIOS will look for the OS. For an OS, it put the sequence in MBR, like the master boot record. Then when the BIOS look for an OS and its boot sequence in MBR. So the MBR shows the BIOS where to find the OS as well as the subsequent program file that will initialize the program. So the MBR, you see, BIOS will look for an OS and MBR. Okay, that's master boot record. Then master boot record and the MBR shows the BIOS where to find the OS as well as the subsequent program file that will initialize the operation. So here the BIOS look for an OS and its boot sequence in the MBR, while the MBR shows the BIOS where to find the OS. Here the BIOS is looking for an OS, while here after it doesn't find the OS its own and its boot sequence in the MBR. Here it's looking for OS and MBR. Do you get it? BIOS is looking for what? OS and MBR. Then OS MBR is master boot record. That's where the OS is. But that's not where the sorry. MBR is the only chip. It's the only chip that knows where OS is. So the MBR will show the BIOS where to find the OS as well as the subsequent programs. So as the process of looking for OS and then MBR, after getting MBR, the MBR will be like, hey man, are you looking for OS? Yeah, I'm looking for OS. I couldn't find it. Where will I get it? Then the MBR shows the BIOS where to find the OS as well as the subsequent program file that you initialize. So after that, after it shows BIOS where the OS is, then boom, it will start. Then it will just open your computer or your device, anything. So that's it. If you have any question, please feel free to ask me via WhatsApp, email, anything, even through calls. I can accept anything you can ask, and then we can move on. So if you have any challenge question, you can ask, please. Feel free. So that's it. Then we have new technologies in computer. So new technologies in computer. We have cloud computing, grid computing, and utility computing. So cloud computing evolved from a concept called virtualization. Like cloud computing evolved from a concept called virtualization. Using virtualization, you can have multiple operating systems at the same time on a single machine. So here, virtualization is like, for example, you you have a system, and then you have a system, you have a computer, and you want to have, you are in need of, let's say, two operating systems, let's say Windows 10 and Windows 8. So instead of going to the market and buy another system of Windows 8, you apply virtualization on your current system. Like that virtualization is what? It helps you to run two operating systems in one computer, to run two windows in one computer. This is just what virtualization is. So it saves you from going to the market, number one, from spending another money for a computer that has Windows 8. So instead of buying two computers, get your computer and apply virtualization on it. You have two operating systems in a single computer. So that's what virtualization is. So cloud computing evolved from a concept called virtualization. So here, using virtualization, you can host multiple operating systems at the same time on a single machine, as I said. A traditional application server may have just have 5 to 10 utilization, whereas virtualized servers can reach 50 to 80% utilization. So by hosting more virtualized instances and few physical servers, you can lower cost of hardware acquisition, maintenance, energy, and cooling system usage. So here, cloud computing, it's you see, instead of cloud computing is everything about like there's this Gmail, Google, Yahoo, blah 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 blah. It's the cloud computing stuff, right? So instead of having a server, instead of having every, let's say this your device, your phone, it has a server, another phone, another computer has a server. They just make one server, like, and then multiple devices. Do you get it? That's cloud computing. As you can see, we have million of users, Google users, million of Gmail users, million of Yahoo users. You get? So that's cloud computing. That's virtualization. It's a single server, but what different people from different location are using it. So that's it. I hope you're getting it. So while grid computing is defined as interconnected computer system where the machine utilizes the same resources collectively, solving a problem or reaching a common goal. Grid computing usually one main computer that preparing information of group of networks to accomplish a common goal. So grid computing is just like when you have, you know, interconnected computers, and then one computer is the admin, is the server. Do you understand? Like we have 4 or 5 computer, and then we have pata of the computer is the one distributing networks to it. Do you get it? Like it's server, then the computers are arranged in a grid format. You know what's grid, right? So that's grid computing. The computer irin ajere haka nan. An gane? Like the computers are ajere then akwai guda ɗaya babba wanda is the one distributing data to the rest of the computer. Like it has control of the remaining systems. Do you get it? Then utility computing. In utility computing, the computer resources and infrastructure is provided by the customer or the service. This customer is charged according to the service usage. So here, utility computing is just like a cyber cafe. You get where you just go and pay and then get the system, do whatever you want to do, and then roll out. That's it. So cloud computing is divided into three major cloud structures. We have public cloud, private cloud, and then we have hybrid cloud. So a public cloud can be accessed by anyone using the internet. Public can be accessed by anyone using internet. The client manages their normal resources that operate within the cloud, provide appropriate remuneration for the services used. Appropriate remuneration for the services is what? The data you buy and then you use for browsing. The public cloud is what? General, everyone can use it like Google. Then private cloud is a cloud technology which uses a private data center for which only an organization has access. Private cloud is like someone from, let's say, for example, Uptech now. Someone from outside cannot have access to, let's say, the server, Uptech server. So it's a private cloud, or let's say, yes, the organization maintains its own data center, and then IT resources within the cloud are available on demand. So like, for example, Uptech now will now buy a bandwidth of internet, then um, only those people, only Uptech staffs, and then maybe Uptech students that can have access to that server. You get, so that's private. Someone from outside cannot have access to it. You get, why sorry, while hybrid clouds are a combination of private and public clouds. Sometimes an application is a private cloud extends to use resources present in a public cloud. So it's a combination of public and private. Sometimes public, sometimes private. You get it? So the application private could extend to use resources present in the public. Listen, for example, someone working and some staff from private cloud can have access to public cloud. That's hybrid. You get, maybe you're browsing with the bandwidth center in the center's bandwidth, then maybe you can have access to another server outside the private cloud. So cloud computing, the different types of services provided in cloud computing platforms. We have infrastructure as a service, that is IaaS. 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 It is a model. Also, all these ones they are what services provided by cloud computing. They are model. Hmm? So all these ones they are models, like just like rules, like structures, like models. Somewhat like theory and then stuff like that. In this model, computers are other and other resources are provided to users, like IaaS is infrastructure. Just like when you are setting a building or anything, number one, you have to have a structure, right? You have to have a structure of what you want. Maybe what kind of building you want, what kind of house do you want to build, right? Right. So infrastructure as a service is the models in this model, computer and other resources are provided to the users. Like what you need, what and what do you need? Then second one here is what platform as a service. So after getting the computers and then resources, what you need, the second thing is you have to make sure that all those computers are well equipped. Like it has operating system, program execution environment, database where you store your records, a web server where you have everything in the server. Then after the structure, after the infrastructure, like after the machines, next is what is inside the machine. Like are they well equipped? DOS, database, web server. Then software as a service. After having all these, then you have to have software in them. Like cloud providers install and operate the application software in the cloud, and the user can access it. Just like the Gmail. Gmail is a software as a service. You get Yahoo. They are all softwares in the server. You get then storage as a service. Large service providers rent out storage infrastructure. Storage where you store your, sometimes you store your things in cloud, right? Mhm. Then security as a service. In this model, that service provider integrates into corporate infrastructure. Security service, of course, all what you've said, you have to make sure that it's secured and then stuff like that. Then data as a service. This model data is provided to the user as when required, irrespective of geographical location or organization separation between the provider and the consumer. So data as a service, you can access your stuff wherever you are. Anywhere you are, you can access it. So test environment as a service. In this model, software and its data are hosted to be accessed by users using a web browser over the internet. So test environment as a service, like sometimes you have a software you want to buy in the internet, then maybe you're not sure of the software. What you need to do is they will provide you a demo, so you will check if everything works perfectly and you like it. Then you go ahead and buy, you test it. It's an environment where you test your programs. And all of them are in what internet and it's in the web browser. You can do that. Then desktop as a service in this model, desktop is virtualized. Desktop is virtualized. It's not the actual desktop you're seeing, but actually they have their own desktop at the server. So a service. Then API, it enables the creation of hosting or application programming interface. So these are the services provided in cloud computing platform. So I hope you're getting it. That's it. Then grid computing. Advantages of grid computing, that is finger symmetric processing. SMP servers for application process are not required. It doesn't need big symmetric multiprocessing. It doesn't need huge processing. That's just it. Idle resources can be utilized more effectively by distributing jobs to idle servers or idle desktops. So here the amplification idle resources. Let's say idle computers. You have 4 or 5 computers. They are working. 3 are working. By the time you connect all of them together, so you see you've made all the idle computers to be functioning. That's just it. Then a great environment has modular structure and does not have a single point of failure. It has a modular structure, like everyone has its own work. It doesn't have a single point of failure. When you have it interconnected, everyone is functioning, right? Then systems can be upgraded without scheduling downtime. It can be upgraded without scheduling downtime. Like you don't have to. Um, it can be upgraded at any time. That's it. Then jobs are executed in parallel speed performance. Jobs are executed in parallel because when you distribute data to the remaining computers, everything is working perfectly parallel and speeding performance. It works perfectly fine. So disadvantage: large SMP, symmetric multiprocessing. are still used when applications that require high memory do not take advantage of MPI. Then a fast connection in between the computer resources is required. So sometimes they are not fast enough because all of them are dependent on one server and which might have some little problem. Then some applications are required to be fine-tuned, take full advantage of new model. So sometimes here when you are online with your system and maybe the system is in a great format, it will just start just like this automatic updates. It will just start updating even though if you didn't give it permission. So the best practice is to make sure you off the automatic updates to avoid that. So that's it. Then advantages of utility computing. The client is not required to buy all the hardware. You don't have to buy hardware or software license. All you need is just to go to the cyber cafe and do the stuff right and just pay some tokens and then browse what you want to browse and leave. So the client depends on the utility computing company to provide these services you get. So the customer it gives companies the options to subscribe to a single service and use the same software suite for the entire client organization. So that is advantage. You buy one and then everyone can come and use it. You get nothing. And everyone that comes with prepays, right? While disadvantage, if the utility computing has financial difficulty or has frequent equipment problems, client could get discontinued from the service even after paying. Then it's prompt to hackers. Hackers can access services without paying and sneaking around and exploiting client files. That's it. So then, summary. The computer consists of different parts, namely CPU, motherboard, RAM, and then disk, main cabinet, peripheral devices. Peripheral devices are connected to the motherboard. A workstation can be defined as a type of computer that is mainly used for technical and scientific applications. Desktop publishing and so on. Booting is the process of loading the operating system when the user switches on. Blah blah blah. So this is a summary for this session. We're done. So if you have any question, feel free to ask. I think that's all for today. If you have questions, please you can ask anything, any idea, suggestions, anything. Just ask. Thank you. Bye.